All right, we're back. And I even had time to erase the board in between recordings. Uh, okay, so let's look at another example. So let's see if we can find the 6 trig function values of theta. Given that cosine 2 theta is 3/4 and that theta is in quadrant 3. So this one is kind of working backwards in some sense from the previous example. In the previous example, we were given information about cosine theta and then asked to calculate cosine 2 theta. And now we're given cosine 2 theta and being asked to calculate cosine theta. Okay. So again, we can use identities to do this. We know, for example, cosine 2 theta is cosine squared theta minus sine squared theta. This particular version of the identity is not going to be useful for us here because we have too many unknowns, right? It's like we know this, but we don't know either of these, so we can't solve for either of them. We need to use some version of this identity that only involves cosine or sine. So we need to use one of the other 2 formulations for it. Now it doesn't really matter which one, and I'm inclined to try to calculate sine first. So I'm going to go ahead and use the one that involves only sine theta. So I have to remember how this goes. So if I only want to use sine theta, I have to replace the cosine squared with 1 minus sine squared. So I'm going to get 1 minus 2 sine squared theta, right? So this one's going to be 1 minus 2 sine squared theta. Okay, and now this is nice because I know what this is. I can solve for this one. Once I've solved for this one, I can make a little right triangle and get all of the rest of the trig functions pretty easily from there. So let's do it. Cosine 2 theta is 3/4. I can subtract 1. I can divide by a -2. Oh, is that right? Yep. That's the same as multiplying by a half, so you're going to get an 1/8, right? Okay, so sine squared theta equals 1/8. That's kind of nasty. I wish it were 1/16. Why couldn't they have made the problem a little nicer, you know? Oh well, 1/8. So we'll say, I say why couldn't they have made the problem nicer, but I'm the one who chose this problem, right? Anyway, okay, 1/8 equals sine squared theta. So we can say, so sine theta is going to be plus or minus square root of 1/8. Now I have to decide which one it's going to be, positive square root of 1/8 or negative square root of 1/8. Since theta is in quadrant 3, I'm thinking we're going to go with negative square root 1/8, right? Because sine is negative in that quadrant. So, we're going to say sine theta. For one thing, we're going to choose the negative one, right? So it's going to be negative 1/8. For another thing, we could simplify this a little bit. Square root of 1 is 1. Square root of 8. Now 8 is 4 times 2, and the square root of 4 is 2, so I think this is 2 root 2 when you kind of rationalize that part of it. We could rationalize this further by multiplying by root 2 over root 2. So then we get root 2 over root 2 times root 2 would be 2. And then 2 times 2 is 4. So I think you get root 2 over 4 when all is said and done. And there's sine theta. And root 2 over 4. We could figure out cosine theta the same way. And I mean, it might be just as easy to do it that way. What I'm saying is, we could do cosine 2 theta equals 2 cosine squared theta minus 1. Use that identity to solve for cosine theta. And then once we have sine theta and cosine theta, we can get tangent pretty easily. We can get all the reciprocals pretty easily. So I think that would be an easy way to do it. The other way to do it is how I mentioned at the beginning, right? You could just make a right triangle now with theta in quadrant 3. Oh, I'm sorry. You're all screaming at the video now, right, that this should be negative. And you're right, it should be negative. We even circled it right here that we should take the negative version. Okay, my apologies. But yeah, anyway, we could draw theta in quadrant 3, fill out the right triangle, solve for the missing side, and then just use the definitions to get the rest of them. So we could do it that way as well. I think I'll do it that way. Okay, so I've got theta in quadrant 3. Sine theta is going to be opposite over hypotenuse. Now I can use Pythagorean theorem to solve for the missing side. So I can say x squared plus y squared equals r squared. So x squared plus 2 equals 16. X squared is 14. So x is plus or minus square root of 14. Is that going to simplify it? No. There's no perfect square that goes into 14, so I don't think that simplifies it all. In quadrant 3, x should be negative, so we're going to take the negative square root of 14, right? Okay, and now we get all the 6 trig functions for free, right? I mean, so we've got, we already wrote down sine theta, but we can say sine theta is negative root 2 over 4. Cosine theta is negative root 14 over 4. Tangent theta. Tangent theta is opposite over adjacent, so negative 2 over negative root 14. So negative root 2 over negative root 14. Gosh, I don't really care about rationalizing all that much, but I think your book does. So if you want to rationalize it, then we multiply by root 14, and then we get square root of, if we're multiplying by 14, 14 times 2 is 28, right? So you get square root of 28 over 14. Oh, but 4 goes into 28, right? So then we could call this 2 root 7 over 14. Oh, and then the 2's will cancel, and that'll leave me a root 7 over 7, right? Okay. I would have been okay with this answer, I think. But your book probably wants you to go to there, root 7 over 7. There's tangent. I'm not going to finish the rest, right? You can do cotangent, secant, cosecant. They're just the reciprocals of these other guys, okay? So that's how we do that. How are we doing on time? How long has it been? I might need to start a new video. Yeah, I'll start a new one.